Hello guys, before I start shooting the video about the full demonstration, I wanted to get this video out of the way, which is about the voltage measurement and calibration. This was the last piece of the puzzle, and I knew that I had to come up with some kind of compensation mechanism because the ESP32 is not particularly good at measuring voltages. In order to calibrate our module, first of all, we have to have some kind of reference voltage that we are sure it is measuring the correct voltage. In most cases, it is going to be some cheapo multimeter that you can read the voltage data from the screen and take that value as a reference. But since I need to measure the whole spectrum of the battery voltage, I'm going to use my benchtop power supply so I can adjust the voltage from the knob and see if it matches to the calibrated values. Okay, so let's start by connecting our virtual battery connector, which is coming from the benchtop power supply, to our battery connector of the module. Make sure it goes red to red and black, which in this case it's green, to black. Next, I'm going to power up the benchtop power supply. As you can see, the output voltage is 0 volts right now. The input voltage of the power supply is about 40 volts, which I need to get it up at least to 70. Okay, so my bike battery has a 16S battery, which means when it is full, it is giving out about 67.2 volts. And if we count the lowest end of the voltage is 3 volts per cell, it should be 48 volts. So I'm going to test from about 67 volts down to 48 volts and see what we get. And now I'm going to power up the module using a power bank. Let me turn it on. As you can see, light came up on board, so it is turned on. Turn on the power, which is set for 67 volts, as you can see right here. Now it is giving out about 67 volts on the output, which is connected through the battery. The app I'm going to show you belongs to the lightboard module. I'm going to get into the details later on in another video, but for now we're just going to focus on the voltage calibration. So our module is on, our power source is on. Now we're gonna fire up the app. So this is our dashboard. And as you can see, it reads 66 volts or something, and then we have 67 volts. Now we have a difference. There's a way to correct that, so we get into the settings. Again, I'm gonna get into all of these settings related to lightboard in another video. Just now go next, and we have a specific setting here which reads battery settings. As you can see, the voltage is printed right here, and it reads fine-tune voltage plus 0.1 volts minus 0.1 volts. So if I want to match it to here, all I have to do is just press once, twice, until I get a value closer to 67 volts. Okay, I think I need to press once as well. Okay, now it is reading, give or take, 67 volts. Now if I press save and restart right here, it's gonna get saved and it's going to restart the module. Okay, let's go stop, completely turn off everything, turn off the board to make sure. Let's see if we can read the correct values into the app. As you can see, we are reading the correct values now. This is just easy as that, but it is not showing the correct percentages. So how we can correct that? Because it is assuming our battery series is 23 cells. So we're going to hit, as I said, this is in the range of 16. We are setting the low end voltage for 3 and the high end for 4.2. Then save and restart. And then we're gonna exit. Then we're gonna get back on it. and now it shows exactly the correct values. But let's see if the values are correct for the whole spectrum of the voltage. So you need to go down to 48 volts. So watch here, and then you can watch here. So as I go down, it should give me roughly the same voltage at 48. Yeah, this is perfect. So, and also the bar is representing the correct percentages. So let's go back up. I can go finer voltage. Yep, it is perfect. It's easy as that. So the next video is going to be about full demonstration, and I'm probably gonna get into the app settings and the screen, and that's it for now.